for coming to this chemical engineering department Science Day. So we'll try to get you to talk to each other, and that actually is the main goal of this day. So talk to each other, not just to the people from your own section. And as a topic we chose food and science. Well, do we have a motivation for that? Well, Volkert and I were thinking and we found some common ground because we all eat.
In the past mayonnaise was a sauce to me, now it's an emulsion.
So you don't have to know actually every difference between the molecular structure of each and every imaginable polysaccharide as a chef, but it's quite useful to know something about evaporation, aromas, how that works.
What I learned from Jan is that oil is a very good carrier of aromas, and that's very handy of use in the kitchen because you use a lot of fats and put in the emulsified butter. And now the coffee aromas are getting into the butter, and you only get the aromas of the coffee and not the bitterness.
So for me, a prototypical food is mayonnaise, and it was already mentioned before. I also like mayonnaise a lot. But it is a very nice example of a soft solid, right? You start with two liquids and you mix them together and you do that properly and you end up with a material that has some very funky properties. Now, to understand that, what you need to realize is if you take two emulsion droplets that are stabilized by some surfactant, if you push them together at very low force or very low pressure, nothing really happens. And there's a thermodynamic force that is opposing making the film between the droplets smaller, and that's what we call the disjoining pressure. From a naive point of view, if I would have stopped the measurement here at that low stress, then I could have set that material stable, but in fact it's not, right? So there's a kinetic aspect to this. So the answer is yes, we can now predict stability, but what we really want is to manipulate them. Now, just to end, we're just starting to understand the origins of tipping points in soft materials, and I think, at least for me, it's a very exciting development.
What I see is spaghetti arms. Everyone's doing this, this, and this.
We will select, the section leader in first instance will select the best ideas. It's a competition.
Arjan and I were extremely amused about the sound in this room. There were, I think, many ideas being generated, very active participation, which is very nice to see. So what our section leaders did is they selected the most creative idea, and what we will ask is to present the work in 90 seconds.
Use the atomic layer deposition to make a coating of alumina.
The idea was that this could be influenced by using, say, adsorbing ions.
So we can actually change the surface.
Insensitive by putting it in a PMMA matrix.
Now on the wafer, on top of it, we evaporate a thin layer of metal.
One of the challenges that we still have there is to enhance mixing in that very laminar system.
That the charge could be transferred much more effectively.
Pick one of the groups. Votes are open, so please go ahead. Team number 6.
This is the small prize that you win now. There will be actually another prize because the next part of the program will be a cocktail presentation.
So you see these bartenders shake like this, but that's, you know, it goes only with the power 1/3. So what's much more important is the time you shake.